we're really going to have our eyes opened when we first encounter an asteroid in its natural habitat. So here we have a robotic spacecraft that's brought back a 500 or 1,000 ton object from deep space and parked it around the moon. Human explorers are going to get access to the surface of this body. They'll peel back the capture enclosure, whether it's a mechanical one or a fabric one. There'll be windows built into it that the astronauts can peel back and then expose the surface. Now we're going to get tens of kilograms of samples from this object, certainly gathered from the surface. We'll collect small fragments, pebbles, dust, and then they'll be able to chip away pristine rock samples from the asteroid so we can measure its composition. That will, of course, tell us a lot about the history of this object by looking at the mineralogy in detail back in Earthbound laboratories. But more important, the astronaut explorers are going to have the ability with their tools to core or drill into the asteroid, maybe several tens of centimeters. If they'll find a fissure, they might be able to even go deeper into the asteroid itself. And getting these interior samples will help us reveal more about how this asteroid is put together, how strong it is, whether it's cohesive, whether it can withstand a gentle nudge or a push from a deflection technique that we might use for planetary defense in the future. So the scientific exploration of this object will be initiated by the astronauts. They'll have about a week to really reveal some of its secrets, bring back lots of samples, and then the promise is that the capture spacecraft will be keeping this asteroid stable in a lunar orbit. We can send other robotic probes out there to continue the examination of the object. And I think the most exciting thing is to start going after what resources we can extract from this object. And so measuring its composition, initially with the astronauts, following up with robots, will give us an idea about whether we can extract valuable natural resources to lower the cost and lower the risk of future deep space expeditions.